Alrighty, so let's calculate the work done by each process and the net work done by the cycle, right? So if you recall, the whole process is, we go here, right, that's 1, here's 2, here's 3, and here's 4. So if I call this A and B and C and D, right, or 1, 2, 3, 4, right? AB, which is process number 1, right? We're going to go work is pressure change in volume, right? So the pressure is 175 pascals, and the change in volume is 1.6 minus 0.4, right? Actually, it's the other way around, right? It is 0.4 minus 1.6, right? The final is 1.4, right? So I'm going to go 175 times parentheses 0.4 minus 1.6, and I get negative 210. So that first process, the work is minus 210 joules, okay? Now for the second process, the piston doesn't move. There's no change in volume, so work is pressure times change in volume, but change in volume is 0, so the work is 0, right? And then process 3, which is process CD. All right, process there, okay. This is going to be, the pressure is 50, right? So it's pressure change in volume, right? So it's 50 pascals, and then it's 1.6. The final, right, minus the initial is 0.4. So 50 times, what is that, 1.2? Is positive 60 joules, right? Okay, so the net work done by the gas, so each process, the process is, oh, and then, sorry, so the fourth process, the work is also 0, right? And that's because what, the change in volume is 0, so the work is 0, right? Because work is pressure change in volume, okay? So if there's no change in volume, isochoric processes do no work. Isobaric processes, it's just simple to find the work, right? Okay, so so now we want to find for the entire cycle. Well, we can just add these up, right? So method number 1, just add them up. So minus 210 plus 0 plus 60 plus 0 is equal to is minus 150. I needed a calculator for that because it's the end of the day and my brain doesn't work so good. There we go. Remember, the other way to do this is to find the area inside this, right? So the other way to do it is area is equal to the length times the width, right? So the length of this is 1.2 cubic meters, right? Is this dimension here, right? And then the width of this thing is, that's a hard word for people that don't speak English to say, width. All right, so what is that? 50 to 175. Is that 125? I want to say it's 125. It is, indeed it is. Look at that. Okay, so it's 125 pascals. I really don't want to go too far out on a limb, so 1.2 times 125. So this is the area inside, and I get 150. And then because it's anti-clockwise, that is, it's going this way, right? It's going to be negative 150. Okay? Now, pause for a moment. We just did all this math. This is fairly simple math. But understand what's going on with this thing, right, is that it's compressing at high temperature. It's expanding at a low temperature. So this thing actually isn't turning heat into work. It's actually using work to make heat flow actually from hot to cold. So this is what your refrigerator does. Heat engines go forward and heat flows from hot to cold and they get work from that. This thing is going backwards, right? It's going anti-clockwise. We're doing work on it, and ultimately what happens is we have heat flowing from hot to cold, which is kind of cool. So this is like a refrigerator.